Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So yes, as you all know, we have started a series where we are going to cover every concept of chemistry that is going to be asked in your KCET examination, as well as we are going to solve a lot of PYQs and practice a lot of questions, right? So yes, we have already completed physical chemistry and now we are in the inorganic chemistry first chapter, that is DNF block. So today it is the part 3 of DNF block chapter where we are going to discuss some important compounds, that is KMnO4 and K2Cr2O7. So regarding this, we'll be discussing the methods of preparation, their chemical reactivities, and we'll be doing previous year questions as well as some other questions also. Okay, so one more information here, please join our WhatsApp channel. It is very important to get the PDF notes, and you can also access to the questions that we are sending, to the solutions. Everything will be available in our WhatsApp channel, so please join our WhatsApp channel. Okay, so now I want every one of you to sit with the notebook and a pen and note down all the important things. Okay, so yes, now let's get started here. So the first thing that I want to tell you is how are we going to cover this chapter. So I have already discussed in my other videos. So this chapter will be covered in 4 parts. So today we are in part 3, already 2 parts have been done and one more part is remaining. So in part 1 we have already seen position in periodic table and electronic configuration. In part 2 we have seen general properties of transition elements, where we have covered all the 14 properties in detail. And then in part 3 we are going to do oxides and oxo anions, and we have oxides and oxo anions, and we'll be doing some important compounds, that is your K2Cr2O7 and KMnO4. And then in part 4 we'll be doing lanthanides and actinoids, so that is part 6 and part 7. Okay, so I hope the distribution is clear. Now coming to the weightage. So weightage, you can easily expect 2 to 3 questions from this chapter. Okay, so from last 3 years, or you can say 4 years, 3 questions, 2 questions are being asked. So yes, this is definitely a must do topic, and it is also very scoring topic. You need to just know certain theories, and based on that only every year questions are being asked. Okay, so next coming here, so as I said you, today's topic we have oxides and oxo anions and important compounds. So in important compounds we have 2 important compounds, that is potassium dichromate and potassium permanganate. Okay, so now going to the first topic, that is oxides and oxo anions. So what is this? Is, say, the transition metals form oxides, means they react with oxygen at higher temperature. Okay, now all the metals except scandium form MO, that is metallic oxides, which are ionic in nature. So here you need to note down 3 important points, that is oxides are formed at higher temperature, scandium doesn't form oxides, and the oxides are basically ionic in nature. Okay, now coming to the next point here. As the oxidation number of the metal increases, okay, the ionic character decreases and hence the melting point decreases. Okay, so I'll tell you here what happens when the oxide is formed, okay, and the metal has a high oxidation state. So in that case the polarization power increases. So what is there? Let us note it down. So when metal is in high oxidation state, okay, what happens? Polarization increases. Okay, if polarization increases, then what will happen? Covalent character will increase. If covalent increases, then what I can say? Ionic decreases. Right? So now you know that ionic compounds have very strong melting point and boiling point, very high melting point and boiling point. So when metals are forming oxides, and if these metallic oxides are having high oxidation state, whose oxidation state? Metal oxidation state is very high. In that case the melting point, boiling point decreases, because the ionic bond doesn't remain ionic anymore, it gets converted to covalent bond, okay, because of increase in polarizing nature. So now what happens? You can see here example, chromium oxide and B2O5 has low melting point. Why? Because you see the chromium oxidation state is +6 here and vanadium oxidation state is +5 here, right? Now you can see an example of the same compound, MnO, Mn2O3, MnO2 and Mn2O7. Now if you see this, manganese oxidation state is +2 and here it is +3 and here it is +4 and here it is +7. right? So now you see, as the oxidation state of the metal increases in these metallic oxides, we can see that the ionic character is decreasing, the ionic character is decreasing, and the covalent character is increasing. Okay, so the ionic nature of the metallic oxides decreases and the covalent nature increases. Now what happens here, if you see the last one, okay, Mn2O7, it is so covalent in nature has increased so much that this compound exists in the liquid form at room temperature. Okay, when there is ionic bond, it is solid. When the bonds are weak, we can find liquid and gases, right? So that is what you can see, most of the covalent bonds like water, NH3, they exist either in the liquid state or in the gaseous state. So same thing happens where when the covalent bonding increases, the nature of covalent bond is so high here that the molecule exists in the liquid form at room temperature, and it is a green oily liquid. Clear? So here the takeaway that you should remember is metal forms oxides. When the higher oxidation state is there, then the bond, the oxide is more covalent in nature. Okay, so if it is covalent in nature, you can see the example here, as the number of oxidation state is increasing, covalent nature is increasing. That is due to the increase in the polarization. Clear? Okay. Now, so 2 points, I think it is very, very clear. Now coming to the third point. Third point here is, okay, as the oxidation number of a metal increases, the acidic character also increases. So there are two things. As the oxidation state of the metal increases, ionic character decreases, or I can say covalent character increases. The third thing is, as the oxidation state of the metal increases, then what will happen? The acidic character will also increase. Now what is the reason behind this? So if we have the definition of acid, what is the definition of acid? Acid is something which can accept electrons, right? Now see, when the metal is in high oxidation state, that means it has lost a lot of electrons. So metal in the high oxidation states, I can say, are deficient of electrons, right? So if they are deficient of electrons, they can gain electrons. If they can gain electrons, they will have acidic character. Now for example, you can see here MnO, here the oxidation state is +2. So if you take water, if you react it with water, we are getting hydroxides. So what I can say, this MnO is basic in nature here, right? Now if you compare it, Mn2O7, if you see the oxidation state of manganese is +7 here. Now when you treat it with water, we get HMnO4. So this is an acid, so this is acid, right? Acidic in nature. Now similarly, if you see chromium, chromium in +2 oxidation state, this is basic, okay, and this is +6, highest oxidation state is acidic. Now here when it is +3, in between when it is there, they generally behave as amphoteric. Okay, now amphoteric means what? Those oxides which can have both they have the properties of both acid and base. Okay, now similarly, if you see for V2O3, V2O3 is in +3 oxidation state, so this is basic, and then V2O4 is in +4, so this is again I can say amphoteric. Okay, and then this one is in +5, which is a high oxidation state, and it is in acidic nature. Okay, so what conclusion we can take here? If the metallic oxides are lower in oxidation state, they are generally basic. If they are higher oxidation state, they are acidic. If they are in between, they are amphoteric oxides. Okay, so yes, now coming to our second topic of today, that is important compounds. So important compounds, we have two important compounds. One is potassium dichromate K2Cr2O7 and another is KMnO4, that is potassium permanganate. Now here there are three things we are going to study about each of them, that is preparation, structure and their chemical reactions. So when I am saying chemical reactions, we are mostly going to study about their oxidizing properties. Okay, we are mostly going to study about their oxidizing properties. Okay, now coming to the first one, methods of preparation here. So here what happens, methods of preparation of potassium dichromate. Okay, so this is only one method of preparation is there. So first we take iron chromate. Okay, when iron chromate is taken with sodium carbonate, it gives you sodium chromate. Okay, so I can write iron chromate gets converted to sodium chromate. Okay, sodium chromate. So you can remember in this way. Now when with sodium chromate, if you give small amount of acid, that is H plus, so sodium chromate, okay, gets converted to sodium dichromate, gets converted to sodium dichromate. Okay, now sodium dichromate gets converted to potassium dichromate. Okay, potassium dichromate. Clear? So that is what happening. First iron chromate gets converted to sodium chromate gets converted to sodium dichromate, and sodium dichromate gets converted to potassium dichromate. Okay, 3 steps you need to remember. These words you need to remember. Okay, now coming to the structure. So chromate and dichromate, we need to know the structure here. So chromate, that is CrO4 2- is in this way. It is also a tetrahedral structure, and dichromate Cr2O7 2-, right? So there are 2 chromium, each chromium is having 3 oxygen atoms, and then they are connected by 1 oxygen atom. Okay, so this is called as dichromate ion. So this is your Cr04 2-, and this is Cr2O7 2-. Okay, so the structure, this is tetrahedral and this is also tetrahedral. Each unit is tetrahedral in structure. Okay, now coming to their chemical properties. So this is the first property that you need to know, that chromate can be converted to dichromate by putting some acid in it. Okay, so if you add acid, add H plus, then chromates gets converted to dichromate, and if you add base, okay, then dichromate gets converted to chromate. Okay, now here if you want to know the color also, you should remember chromate is yellow in color, okay, and dichromate is orange in color. Okay, so that is what you can see here also. So I hope this is clear. Chromate, so for chromates, if you add H plus, it gets converted to dichromates, and dichromates, if you add OH minus, it gets converted to chromates. Okay, so what I can say, that just you take a test tube which is having chromate, add few drops of H plus, you will immediately see the change in color, the yellow color changing to orange. That is because of the formation of dichromate. Now similarly, if dichromate is there, okay, and you add some amount of base, then it will immediately start converting to yellow color. That is because of formation of chromate. Okay, so I hope everybody would have remembered. Let us revise again. Chromate, H plus, dichromate, dichromate, OH minus, chromate. Okay, fine. So now coming to, now let us see the next one. So okay, here there is a small error. I'll correct it. So this is, we are discussing about K2Cr2O7, right? So K2Cr2O7 is a strong oxidizing agent. Now a question may arise, why is it a strong oxidizing agent? Let us understand that. Now first let us calculate the oxidation state of K2Cr2O7. Means oxidation state of chromium in this particular molecule. So oxidation state of potassium is 1. So there are 2. So I can have 2 plus. We have now chromium is 2x. 7 into minus 2, 14 is equal to 0. So I can say x is equal to plus 6. Right. So chromium oxidation state is plus 6. Now if you have seen the table, chromium, okay, chromium has whatever oxidation states is there, chromium highest oxidation state it can attain is plus 6, right? So now what happens, chromium highest oxidation state it can attain is plus 6. Now already in K2Cr2O7 chromium is plus 6 oxidation state. That means it cannot go further. It cannot be going, it cannot go to higher oxidation states further. What it can do, it can come back to lower oxidation states, right? It can come back to lower oxidation states. Now when an element comes back to lower oxidation state, what is this process called as? Reduction. And the element, if it is undergoing reduction, it behaves as an oxidizing agent, right? I hope this is clear. Let me repeat it again. So when in potassium dichromate, chromium is in plus 6 oxidation state. So it has already attained the highest oxidation state. It cannot further come down, right? Now if it cannot further it cannot go higher further, it can only come down. The oxidation state can decrease from here. So if the oxidation state decreases, it is behaving as it is undergoing reduction, and if an element undergoes reduction, it behaves as an oxidizing agent. Clear? Okay. Now if we see the reactions here, okay, so now you see, I told you it will behave as an oxidizing agent, means other compounds will get oxidized. So chromium itself get reduced to Cr plus 3, right? So plus 6 to plus 3 is reduction, but it oxidizes I minus to I2. So if you see, I minus is minus 1 and here the oxidation state is 0. So I minus to I2, there is oxidation, right? So potassium dichromate, or you can say dichromate, oxidizes I minus to I2. Okay. Now coming to next one, if you see here, again H2S, if you calculate, the oxidation state of sulfur is minus 2 and here the oxidation state of sulfur is 0, right? So that means what? Again from minus 2 to 0 there is an oxidation of sulfur. Who is doing this oxidation? Potassium dichromate is doing this oxidation. Now if you see the next one, Sn plus 2 to Sn plus 4, right? Now potassium dichromate is oxidizing Sn2 plus to Sn plus 4, right? Okay. Next, if you see, Fe2 plus is getting oxidized to Fe3 plus. So there is a, this plus will come here and here also this plus will come here and this one is like this. Okay. So now you see, so Fe2 plus is getting oxidized to Fe3 plus by whom? By potassium dichromate, or you can say only dichromate. So dichromate will itself undergo reduction and will oxidize the other species. Clear? So with this, potassium dichromate is done. Okay. Now let us see the next first question here. Acidified potassium dichromate cannot oxidize. Ethanoic acid. So if you have studied organic chemistry, you will be knowing that first alcohols, okay, is oxidized to aldehydes. Aldehydes is oxidized to carboxylic acids. Now acids cannot be further oxidized, right? So that is why ethanoic acid is the correct answer here. Now if you see iodide, I minus can be oxidized, whereas Fe2 plus can be oxidized, right? But ethanoic acid cannot be oxidized further. Okay. Now next question, which of the following statement is false? An acidified solution of K2Cr2O7 converts iodine to iodide. So remember here, I minus is called as iodide, okay, and I2 is called as iodine, right? So potassium dichromate converts iodide to iodine. I minus to I2 conversion takes place, which is your oxidation reaction. Okay. So what is it is given here? Iodine to iodide. It converts in this way. The statement is saying it converts iodine to iodide, right? So this statement is wrong. So that is why this is the correct answer now. In acidic solution, chromate ions are converted to dichromate. Yes, this we have already discussed. Now, ammonium dichromate on heating undergoes exothermic reactions to give chromium oxide. This is also correct. Potassium dichromate is used as a titrant for Fe2 plus ion. So this is in titration, you might have done this one. So the wrong statement here is the first statement. Now coming to the third question, which of the following oxides of chromium is amphoteric? So you see here the oxidation state is plus 6, here it is plus 4, here it is plus 2 and here it is plus 3, right? So just we have seen that CrO2 is your amphoteric in nature. So the correct answer for this question will be option number B. Okay. Fine. Now coming to the second compound, that is potassium permanganate, KMnO4. So first of all, there are three methods of preparation here. The first method is fusion with KMnO2 or MnO2. So MnO2 is treated with an base or an alkaline medium in presence of O2 to get converted to K2MnO4. Okay. Now K2MnO4 can be written as MnO4 2 minus, right? The charge here is MnO4 2 minus. It is treated in acidic medium to get converted to permanganate. Okay. So the what we can say, first MnO2 is converted to manganate. Manganate is then converted to permanganate. Okay. So now there is another method of doing this by commercial method. So here you can see the same thing, MnO2 is taken, okay, it is fused with KOH and it is oxidized. The same process happens and we get manganate ions here. The second step is different here. Here manganate ions are converted to permanganate in the acidic medium. Here manganate ions are converted to permanganate ions in alkaline medium by using electrolytic oxidation. Okay. Using electrolytic oxidation, manganetes are converted to permanganate. Now there is one more method, commercial method. So here what happens, again Mn2 plus is taken in presence of S2O8. This converts Mn2 plus to MnO4 minus. Okay, again we can get permanganate ions here. Clear? So these are theoretical things, you need to remember these reactions, but you just have a mindset that first we are getting manganate, from manganate to permanganate. Okay. Now coming to the structure here, so MnO4 minus is your, this one is your green color manganate ion, that is MnO4 2 minus. Okay. So here if you see the oxidation state of manganese is +6, right? Mn is in +6 oxidation state. So what is the electronic configuration here? 3D, the 3D5-4s2 is for manganese and 3D1 is for Mn +6. Okay. So now if this is there, then what I can say, this one unpaired electron, so this one will be paramagnetic. Okay, this one will be paramagnetic. Now if we talk about this one, MnO4 minus, okay, so what is the oxidation state of MnO4 minus? Okay, now you see here, yeah, if I write MnO4 minus, what's the oxidation state of manganese here? +7. So it has argon electronic configuration only, right? So this has no unpaired electron. If no unpaired electron is there, then this is your diamagnetic. Okay, so remember, manganate is paramagnetic, permanganate is diamagnetic, first thing. Next, the color. So this is green in color and this is purple in color. Okay, this you might have seen in your labs many times, you might have done titration. So permanganate color is purple in color, manganate color is green in color. Manganate is diamagnetic, manganate is paramagnetic and permanganate is diamagnetic. Okay, so you need not remember this. If you know the electronic configuration, you can easily do this. Next, coming to the chemical properties. Okay, so first chemical property that we are going to see is KMnO4 is a strong oxidizing agent. Now what is the reason behind it? The reason behind it is again the oxidation state of manganese here. Manganese is in +7 oxidation state. It has already attained the highest oxidation state. From here it cannot be further oxidized. It can only come back to the lower oxidation states. Now if it comes back to the lower oxidation state, then we can say that it is undergoing reduction and it will behave as an oxidizing agent. Okay, very strong oxidizing agent. Now potassium permanganate forms dark purple, almost black crystals which are isostructural with KClO4. So this can be an MCQ question, that permanganate ions are isostructural, means their structure is similar to KClO4. Okay. Next, then your question may arise, we have just studied in the last class that if there is presence of colored ions, okay, if there is colored ions, then if there is unpaired electrons, then the metal possesses color, right? If there is unpaired electron, there will be DD transition, and that is why the metal possesses color. Now if you see manganese in +7 oxidation state, manganese electronic configuration is 3D5-4s2, right? +7 oxidation state, it is argon, right? Now if argon is there, there is no unpaired electron, that means there should not be any DD transition, but still it is so bright in color, there is purple, dark purple color crystals are formed. How this happens? So there are different factors which are responsible for the color of a compound. So in this case, in case of manganese, it is not due to DD transition, rather there is something phenomenon called as charge transfer. So it is due to charge transfer. Okay, now what is charge transfer and all, that is not in the scope of your syllabus, but you need to understand that manganese has no d electrons. It does not undergo DD transition, but still it is colorful due to the charge transfer. Clear? Now coming to next thing, as we say there is no unpaired electron here, magnetic moment will be 0, so we can say that this is diamagnetic. Okay, but sometimes when you increase the temperature, okay, when you increase the temperature, we can find a slight temperature dependent paramagnetism. Okay, slight paramagnetism nature comes in these compounds when the temperature is increased. Okay, so that is again the reason here is that you can say the electrons which are like opposite spin, they move and they get same spin. Some concept is there which is again not in the scope of the syllabus, but you need to know that permanganate ions are generally, they are diamagnetic, there is no unpaired electron, but when you increase the temperature they show some weak paramagnetism behavior. Okay, next thermal decomposition. So KMnO4 minus, okay, KMnO4, if you heat them we will get MnO2, K2MnO4 and O2. Okay, so just you can remember this reaction. Okay, now coming to the chemical properties, that is the oxidizing nature. This is very important slide, this one. Here you need to understand that manganese or permanganate are +7 in charge, right? But they will undergo reduction, but in acidic medium it gets converted to Mn2 plus, in neutral medium it gets converted to +4, and then in basic medium it gets converted to +6, right? +7 to +2, +7 to +4, +7 to +6 in the basic medium. Okay, this you have to remember. Let us revise once again. +7 to +2 in acidic medium, +7 to +4 in basic medium, and +7 to +4 in neutral medium, and +7 to +6 in basic medium. Once again let us revise. +7 to +2 in acidic medium, +7 to +4 in neutral medium, and +7 to +6 in basic medium. Okay, now coming to reactions. Okay, so in acidic medium, as I already told you, this one will get converted to +2. I minus is getting converted to I2. This reaction is very familiar, we have already seen with potassium dichromate. Okay, next NO2. If you see the oxidation state of nitrogen here is +3, okay, and it is getting converted to +5, right? NO3 minus. So +3 to +5, again oxidation, because it is acidic medium, Mn is getting converted to +7 to +2. Now if you see the next one, this is your again +4 to +6, right? Oxidation happens here, and Mn converts to +7 to +2. Okay, fine. Now coming to some more example, S2 minus will be getting converted to S, okay, will be converted to S, Mn +7 to +2. Next, if you see Fe2 plus will get converted to Fe3 plus, C2O4 minus gets converted to CO2. Now if you see the oxidation state of carbon here, it is +3 and here it is +4. So +3 to +4, there is an oxidation, change in the oxidation number. Getting? Okay. Now coming to, if the medium is neutral, okay, we have seen in acidic medium what changes happens. Now we have seen that for manganese in neutral medium it gets converted to MnO2, right? So if you give neutral medium, what will happen? In acidic medium I minus was getting converted to I2, but in neutral medium I minus will get converted to IO3 minus, very important reaction, and MnO4 will get converted to MnO2, right? Now similarly in this one S2O3, that is your, if you see the previous reaction, I think we have, okay, we have SO3, fine. Okay, now if you see S2O3, okay, this is your, what's the oxidation state here? 2x minus 6 is equal to -2, so x is equal to +2. So this one will get converted to +6, right? So now what happens? In case of S2O3 in alkaline medium, +2 will get converted to +6, S2O3 will get converted to SO4 2 minus. But this one is important because from here questions have been asked many times, okay? Please remember this one, okay? Fine. Now one more reaction is there. It also converts MnO4 minus converts Mn2 plus to Mn plus 4. Okay, so we have three reactions in neutral medium. I minus gets converted to IO3 minus, S2O3 gets converted to SO4 2 minus, Mn2 plus gets converted to MnO2. Clear? Okay. Now we'll solve some questions here. So when KMnO4 solution is added to oxalic acid, the decolorization is slow in the beginning but becomes instantaneous after some time because. Okay. Now see here, when oxalic acid solution, if you have seen Mn acidic medium, so Mn plus 7 will get converted to Mn plus 2, right? So now this Mn2 plus can behave as a catalyst. Okay, so that is why after certain time this will behave as a catalyst and the reaction will fasten. If the reaction gets faster, the color change also will be more intense. Okay, the correct answer for this question is Mn2 plus acts as an autocatalyst. Okay. Okay, next. KMnO4 acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with Ki, iodide ion I minus is converted to, I told you it is very important, converted to IO3 minus. Okay. Next, question number 3. Why HCl is not used to make the medium acidic in the oxidation reactions of KMnO4? Okay, this is KMnO4 in acidic medium. So question is asking, suppose I have a solution of MnO4 minus. Okay, and I want that this medium should be acidic. Okay, I want the medium to be acidic, so I need to add some H plus, some acidic medium I need to add. So you cannot add say only H plus. There is no like H plus are available, you will add. When you add H plus, you mean that you need to add acids. Okay, so now suppose there is one something compound A is there. Okay, MnO4 is there, A is there, and we want to make this medium acidic. So now if I add HCl, in this case, if I add HCl, the question is telling that we cannot add HCl. What is the reason? So now see, if you add HCl, where will this what will this MnO4 minus do? HCl is Cl minus, it will convert Cl minus to Cl2, right? It will not react with A, it will start reacting with this chlorine, right? So the result, suppose you are doing titration or something, the result you will get will be incorrect. So that is why we are not using MnO4 minus oxidizes HCl to HCl2. Okay, so now my question 1 arises. I want everyone to be answering this in the comment section, that if we cannot use HCl but we can use H2SO4, we can use H2SO4 to make the medium acidic. Okay, but we cannot use HCl, but you can use H2SO4. This is the answer I am giving. The question now is, why can we use H2SO4, or why H2SO4 can be used? Are you getting? I am telling, to make the medium acidic, we are not able to add HCl, because HCl will MnO4 minus will oxidize this Cl minus to Cl2. But I am telling that we can add H2SO4 to make the medium acidic. Then what is the reason? Okay, I want everyone who is watching this, please answer or think about this, and if you do not know, please comment down that you don't know. I'll answer you in the comment section. But let me see how many of you are able to use the logic of oxidation and reduction. Okay, fine. Now let us do some PYQs. Okay, important questions have been asked in the previous section. So we have Cu2Cl2 and CuCl2 in the aqueous medium. Okay, so if you see Cu2Cl2 means copper is in +1 oxidation state here, and CuCl2 means copper is in +2 oxidation state, right? So this one we have discussed in the previous class, the oxidation state. So what I told you, that Cu plus is more stable in the Cu2 plus is more stable in the aqueous medium due to high hydration enthalpy, right? Due to high hydration enthalpy. Now if you see here, so stability of these two are equal, that is wrong. Like both are unstable, that is wrong. Cu2Cl2 is more stable, that is wrong. CuCl2 is more stable than Cu2, this is correct because of more negative hydration enthalpy, and especially it is given in aqueous medium, right? Okay. Now let us see the next question. A mixture of NaCl and K2Cr2O7 is heated with concentrated H2SO4. Deep red vapors are formed. Okay, which of the following statements is false? So now you see this is your chromyl chloride test. Okay. So now what happens when you heat K2Cr2O7 with concentrated H2SO4, you get CrO2Cl2. Okay. Now when you, this is red vapors. Okay. When you treat it with sodium like OH minus, it gets converted to CrO4 minus. That is your chromate, right, which is yellow in color, right? Now if you treat it with lead or lead chromate, you will get lead chromate, which is again yellow in color. Now the question is asking, the vapor gives a yellow solution with NaOH. Yes, because of the formation of chromate ions. This statement is correct. The vapors contain CrO2Cl2 only. Yes, that is also correct. The vapor contains CrO2 and Cl2. There is no presence of Cl2 vapors here. So the incorrect statement is this one. Okay. Now the vapors when passed into lead acetate in acidic acid gives a yellow precipitate. So if you pass with lead acetate, lead chromate will form, which is again yellow in color. Okay. So the correct answer for this question is option number C. Okay. Now coming to the question number 3. Which of the following statements is wrong? In the highest oxidation state, the transition metals show acidic character. Today we discussed in the first part of the lecture, when the metal is in highest oxidation state, it behaves or it has an acidic character. Next, Mn+3 and CO+3 are oxidizing agents in the aqueous solution. Okay. Now you see, Mn+3, right, can come to Mn2+ easily. Why can it come to Mn+2? Because it is a D5 stable configuration, right? So itself it will undergo reduction. If it is undergoing reduction, it will behave as an oxidizing agent, right? The statement is correct here. Now, metals in the highest oxidation state are more stable in oxides than in fluorides, right? This also we have discussed in the last class, that oxides can stabilize more due to its ability to form multiple bonds. So this statement is also correct. Now all elements of 3D elements exhibit variable oxidation state. This one also we discussed in the last class, that scandium and zinc have only one oxidation state. So we cannot say that all elements of 3D have variable oxidation state, right? So this statement is incorrect. So the correct answer for this question is option number D. Okay. Now coming to question number 4. Which of the following is an amphoteric oxides? So we know for amphoteric oxides we need oxidation state of middle, like between oxidation states. If you see here Cr2O3, that is +3 oxidation state, yes, and here it is +5 oxidation state. Okay. Now this can be the answer. Here if you see Mn2O7, this is +7, so this is acidic, we can eliminate. Here if you see CrO, this is +2, so this is basic in nature, we can eliminate. And here V2O5 and V2O4, V2O5 is considered amphoteric, okay, but V2O5 is considered basic. So the correct answer for this question is option number A. Okay. Now question number 5. Mn2+ compounds are more stable than Fe2+ compounds towards oxidation to their +3 state. So they are saying that Mn2+ and Fe2+. Okay. If we want to make them Mn+3 and I want to make this one Fe+3, right? So they are saying that Mn2+ is more stable, means this one will not take place, this one will take place easily, this one will not take place. What is the reason behind this? So all of you would be knowing very easily, this is D5 configuration, very stable configuration. It doesn't want to change its configuration, so that is why this will not happen. Now Mn2+ is more stable with high third ionization energy, right? Mn2+ is more stable, that is correct. Why? Because of D5 configuration. So this can be the answer. Mn2+ is bigger in size, this has nothing to do with this. Mn2+ has completely filled, no, it has partially filled. Mn2+ does not exist, it exists, right? The correct statement is option number A. So yes, now test yourself. So there is a question for you. When KMnO4 acts as an oxidizing agent and ultimately forms MnO4 2-, MnO2, Mn2O3, Mn2+, then the number of electrons transferred in each case respectively is. So this is something related to electrochemistry also and related to D and F block also. So you need to try this question and do not forget to comment down. Another question I asked you, why H2SO4 acid can be used to acidify any solution of permanganate, whereas HCl cannot be used. Comment down the answers, and if you do not know, please comment down that you don't know. I will tell you the answer there. Okay, fine. So yes students, so this was the part 3 of DNF block elements. So we have one more part where we are going to discuss about lanthanides and actinides. So please study every day with me, spend just 1 hour, 1 to 1.5 hours. Then you can, after you do this for continuously for till you complete your portions, I assure you that you will be able to get very good marks in your KCET examination. So yes, please stay tuned for the next class, and thank you for watching. Subscribe the channel for more updates, more such videos, and do not forget to join our WhatsApp channel. Okay, so all the very best, keep learning hard and keep doing practice.